So as far as global solar scenario is concerned, I would like to say that solar is an ocean and there is a large growth potential seen that today we are at 500 gigawatts globally, and we expect that this will go to somewhere around 4,000 to 5,000 gigawatts. Today, it is beyond any doubt that China is the example. Anywhere, you just can't beat the Chinese, and their solar capacity is also very high at 174 gigawatts. And US is distant number 2 at 60 gigawatts. Countries in Eastern Europe and in Latin America, similarly in UAE, they can follow India, because India has grown from 0 to 28 gigawatts in a period of just 4-5 years. We have to learn from each other, even within Eastern Europe. For instance, Ukraine, you find that there is a very good support from the government. Government is progressively thinking. So 2 gigawatts already achieved, going to 3 gigawatts. But as I requested the minister that please increase the target to 5 gigawatts minimum, which is the potential of Ukraine. And for that we can bring in investment. That's not a problem, as long as government has a good policy. Investment is there, and to my mind, for a good project, funds are available. Funds is not a problem. I would like to congratulate, number one, to the IBCentre. Main thing is that there should be more such seminars and conferences, because we have to spread awareness. At the end of the day, we have to spread awareness, and we have to have good networking. The main message that I had given, that we have to join hands. So joining hands is possible through this kind of conferences and seminars. And it is a wide range of people from various countries, from various solar companies and various walks of life.
Yeah, we have many main trends actually. We have new technology for the modules, and bifacial I think will be the trend for this year. And also we have the new scheme of the new trend for auctions in all the countries. We don't have anymore so many feed-in tariffs in the countries, but actually we have auctions. And this will be the development in the next years. Actually, it will be the main scheme for all the countries that they will develop solar. I think Sea Solar this year was the best ever. We have new companies participating in the conference and in the exhibition, and this shows the interest, the big interest for the region and for Ukraine especially, because it's a booming market. The Sea Solar is contributing very much to the solar industry because you can get all the information you need. People coming and companies from all the neighbor countries and the region, so they can get very good information about solar trends, the new developments of the energy, and so on. So I think it's the best event to participate in order to get very good information and new information about the trends of the solar industry and of the energy in general.
Hi, Julia. How is the sound? Great. Good morning, dear colleagues. So, let's start our third day. I'm very happy to welcome you on our event, Innovation 2020, our online digital international conference in the field of renewable energy. For the last 2 days, we had a lot of very interesting presentations, talks about challenges, about solutions, about latest technologies, and how to develop our projects, how to develop projects in the field of renewable energy today. Today we have a very big challenge. The name of this challenge is pandemic. Nobody knows how this pandemic will impact economy, on the renewable energy industry. But anyway, we know that renewable energy can become a very big, very effective driver for the economy, for the energy industry. Today we will discuss wind energy. We will discuss the latest technologies in the energy sphere at all, and I'm very happy to introduce, to invite our first speaker. This is Stefan Xanger, Secretary General of the World Wind Energy Association, our big friend, and I will be very happy to hear what is happening today in the field of wind energy, what we can to expect in the nearest time, what we can expect next year in this industry. So I'm happy to invite Stefan to make his presentation. Hi, how are you, Stefan? Very happy to see you.
Hello. Very good to see you. Yeah, great pleasure. And I'm fine. I'm sitting in my office in Bonn, just returned from summer vacation, which this year I spent with my family in Germany. We're not traveling abroad because of the situation. And it's great that this is the first event that I'm participating after my holiday break. I know others are still on holiday or they will go on holiday later. But it's good to see many people here. And of course, the topic that you have chosen for this meeting here is extremely important. And we have already had discussions with various colleagues from different parts of the world, from the other renewable energy sectors, about what the impact of the current corona crisis is on renewable energy, on the whole economic development. So I'm not 100% sure. I've never used this kind of, it's great. I mean, we're learning so much these days. How to still interact closely, although we're all sitting at home. So if you can just tell me, I can control this by myself. Very good. Is everybody seeing this in the right mode? So I can just continue. Vitaly? Well, I assume so. I don't hear anything else.
Yes.
So,
yes.
Good. So just very briefly about World Wind Energy Association. We are a global umbrella organization with the headquarters in Bonn, here in Bonn. Actually, you see on the map, it's the UN campus. So we have the UN Climate Secretariat is just 300 meters from here. The Arena Innovation and Technology Center is 500 meters from here. So we are headquartered where important international, also governmental organizations are based. That is, of course, an advantage, in particular in days like now, and of course also expecting that it will take a while until we can start traveling again globally. We have around more than 600 members. Many of them are national wind associations, so we are a big network of networks, if you want. And our members are from more than 100 countries all over the world. Actually, we do every year our World Wind Energy Conference, and we had that on all continents so far, but this year is the first year. We're planning to have it in Korea, and you may remember that when the pandemic spread to Korea, it was the second country that was affected. Our colleague says that already in February. We're sorry, but we are at this point of time not in the position that we can host a physical meeting. So this year will be the first since 2002 without a World Wind Energy Conference, but we hope to take it up again next year. So that's an impact that this has on, of course, our work directly. And as I said, of course, I was traveling a lot to meetings. I'm not traveling anymore. I'm sitting in Bonn, but there's a lot going on now online. We have now also regular webinars. We do this on a bi-weekly usual basis. At the moment, we have summer break, but it's great that you can, of course, also meet with people from around the world, which would never meet at one conference because not everybody is able to travel, but we can still do that. Now, what is the impact of the current crisis on renewable energy, on wind energy? First, let me explain you a little bit what the status is of wind power, or what it used to be at the end of 2019. Wind power is, of course, an amazing success story. And you look at it, this is commercial modern wind development since 1980 around. So we can say it started with Jimmy Carter in the United States and in parallel with Denmark. And you see those red arrows. That's always when there's a tenfold increase in installed capacity. So we started with couple of megawatt in 1980, and 40 years later we have 650 gigawatts, 650,000 megawatt installed worldwide. I'm of course aware that there is a history before that. Many countries started generating wind electricity already end of the 19th century, and the Soviet Union was in Ukraine actually, was the first, there was the first also research center for wind power. And there was a wind industry, but that kind of completely disappeared. And when we look at today's industry, then we go back to the 1980s. So wind is today contributing in some countries, well, Denmark, for example, more than 40% of the power demand. Germany, my home country, 20% or even more now. Globally, it's about 6%, which is, of course, substantial. And yeah, the electricity generated around 1,300 terawatt hours. So the development of the last couple of years was quite stable. We saw increased rates of around new installations 50, 45, 50, 60 gigawatt per year. That's a lot. With growth rates of around, you see here the added capacity. Last year was a very good year with almost 60 gigawatt installed new capacity with growth rates, annual growth rates of around 10% or even a bit more. So it's good to see that last year even it went a bit up after it was a bit slower in the year 2018. When we look at the continental distribution, it's also interesting that Europe was for many years dominating. We saw more than half of the installed capacity for around 2 decades in Europe. But now Asia is by far the largest continent. And that's, of course, mainly due to 2 countries, that is China and India. But I'll show you this a bit more. Of course, that somehow is also natural development because many more people are living in Asia than in Europe and also North America. What you see here is, of course, there's not yet so much, so there's a lot more needs to be done, in particular Latin America and Africa, but it's good to see that also African markets are now slowly evolving and growing. The leading markets here, as you see, by far the biggest market in 2019 in terms of new installed capacity was China with 27,000 megawatt installed within 1 year. That is really a lot. You see here those leading countries. Let me already mention here, these are the biggest markets of 2019. And when you look at these countries, Brazil, China, France, Germany, India, Spain, UK, United States, you see them also in the top list of those countries hit by the pandemic. So that's all obvious that there must be some impact on the development, on the global development, because these countries are, of course, playing a very big role in international wind power installations. Look at it again here from a different angle, the countries and their installed capacity. You see China accounts for more than 1/3 of the global capacity, 240 probably now gigawatt of installed capacity, followed by the United States. Germany is now number 3. India is also doing quite well, and Spain is taking up again now. One country, of course, we should always mention, which is, of course, a small country, that is Denmark with around 5 million inhabitants, but they have by far the largest share of wind power, more than 40%, and they will certainly go much, much higher than that. We are, as World Wind Energy Association, not only looking into the large wind turbines, the large wind farms and turbines, but also at small wind. Small wind, this is of course more or less how the development started, because we saw the first installed wind turbines in the 80s where had a capacity of the kilowatt or dozens of kilowatt range. Now this is its own market segment, which of course sees special challenges because of the price of photovoltaic going down so much. It's applications which are of course done usually not so much grid connected, but often at isolated places off grid areas. But still you see that we have a total number of installed units. It's a bit more challenging to gather the data here. That's why we do not have 2019 yet, but end of 2018 we had 1.1 million units installed worldwide. So that this is not neglectable, and imagine that every small wind turbine supplies power for a couple of people. So there are millions of people that are getting power from small wind turbines. By the way, we define small wind as a rated capacity of up to 100 kilowatt. What are the countries that are leading in that? And again, here you see a dominating country, and that is China. China, where in particular these small wind turbines are used in remote areas. China still has a small part of the population that has no access. It's really a small part, but small part of the population that then relies on even now, PV is of course a solution, or small wind turbines, and they're often used together with a battery. Lead acid battery is a very simple way of getting power. When you look at the US market, that of course is a very different angle, but that's how it started, electrification. Yes, often they had small wind turbines, and now many farms also are using them. And I can just tell you from Germany, as I told you, I spend my holidays in the North Sea at the coast of Germany. And it's quite amazing to see that now, and that's a new development, almost every farmhouse has a small wind turbine again. You see many large wind farms in the background, but in that area where you have big farms and they have a high consumption of power, many of them use small wind, and there is no specific remuneration for small wind in Germany. Probably they use it just to cover their own electricity demand, because it saves them money, because it's cheaper to generate power from small wind than buying it from the grid. Let me say that before we talk about what is the current situation, we have one focus that we really find important in our work. Next to our general goal, as World Wind Energy Association, we are focusing on the general goal of converting the energy system completely to 100% renewable energy supply. I know that you heard about that goal before. I can assure you that we've already had some impact on how the world is discussing this, because when you came up with 100% renewable energy globally 10 years ago, even 5 years ago, even some people from the renewables community looked at you and thought, oh, this is a weird guy. Now it's broadly discussed and seen by many as a requirement, a precondition to achieve, for example, the Paris goals, the Paris Climate Agreement goals, because renewables are by definition without emissions, and we can achieve an emission-free energy supply, and that is what is needed only if we use renewable energy. Also, I would say nuclear power plays a role, but nuclear power already plays a very marginal role, with I think around 2% of the total energy supply. And if you assume that the International Energy Agency is right with their prediction of doubling the share of the overall energy consumption by the year 2050, that means that in order to keep the share of nuclear power stable, you need to double the installed capacity, and that's not what's actually happening. The installed capacity is stable for the last 20 years, has been stable, and will not grow a lot, because many countries are also now decommissioning nuclear power stations. So if current fleet stays online, then you would have in 2050 1% of nuclear power, and I think that's marginal. We can say this is still in line with 100% renewable energy. The other aspect that is so important is, of course, that we look at the different, first, technical, physical, of course, aspect here, and that's the decentralized character of renewable energy. And that is in particular important in the case of wind power. For solar energy, it's very obvious that every household, every roof can have its solar system. But in the case of wind power also, we find it very important because the people who are living on the countryside, who have wind farms in their environment, they need to live with them. It needs to be part of their life, and you cannot enforce it, you cannot impose it. And we've seen that in several countries, including Denmark, for example, Germany, that the development was driven by those communities, often farmers who are owning the wind farms. And that has led to not only acceptance, but strong support and a social momentum. And we see that that is missing at the moment in some countries, and there's even opposition against wind farms, which is not based on facts. It's a bit like the climate change deniers who come up with very funny arguments against wind energy. That's why we find it so important to focus on also local benefits and local ownership and what we call on community power. So that is really a key, and I think that's not only the case for wind, but for solar as well, but maybe a bit more natural. But we need to make sure that the people are living with the wind turbines, that they have a direct benefit from that. That's not only something for industrialized countries, but we know, for example, from projects in some developing countries, a wind farm is built and the village next to it doesn't even get power. That's, of course, not a good idea. The nice thing of wind energy is that it's available everywhere. It can be harvested everywhere. And we will come back to that when I now talk more specifically about the Corona crisis, because I think there is a linkage between this special characteristic of renewable energy, of wind power, and where we are now. The socioeconomic situation and the two crises that we're facing at the moment, the climate crisis on the one hand and the health crisis on the other hand. So just very briefly to mention that here, when we talk about community power, what we mean is actually owning, controlling, having participation in the project and getting benefits out of that. Okay, now let me come to indeed what's the impact of the Corona pandemic on the wind sector. We've had, it's now 2-3 months ago, we had already a webinar when everybody was in lockdown with our members from around the world, and you can still watch the recordings. There were reports from China, from North America, from India, Japan, Korea, European markets, etc. And at that time, it was already quite clear there is an impact. First and direct impact is, of course, that there is an interruption of supply chains. There is, of course, an interruption on the one hand on international supply chains. There is also an interruption of national supply chains. And this is often something to do with not only that it's now more challenging to bring wind turbines from one place to the other place. Of course, factories are closed. That's still the case in some parts of the world. And even China is saying we not only after we went back to work, we still have problems because we are sourcing certain products, components from outside China. And there we have a problem. At that time, it was from Spain. Domestic activities are often interrupted also by workforce problems, of course, because, this is still something ongoing, as we know. If you have some, not only in case of a general lockdown, but also if at a certain factory there is some infection cases, then the whole factory may be closed for some time. So what we see is that in the short term, there is no doubt that this situation will lead to a delay in project implementation, and accordingly it will lead to a decrease in new installations in the year 2020. We cannot yet quantify that. We will do a survey starting now in summer, but of course now many people in the Northern Hemisphere are on summer holiday, but after that to try to find out, to quantify that. But it will have an impact, and that's of course very clear if even China says that, because China accounted for around half of the world market last year. If there is a decrease, there is a remarkable decrease, of course, on the global level as well. That having said, of course, we can also see that the first governments are directly responding. For example, there are certain periods within which you have to implement a project in order to get your power purchase agreement, etc. And governments have already indicated that they would extend such deadlines. We have also seen that there has been some new conditions related to auctions. I mean, we see in particular problems with the auction system, but when there are auctions, there's already some also new regulations and new deadlines have been set up. But latest in the midterm, we see that there is a new development now, and that is not only in terms of renewable energy, but overall, everybody is aware of how governments notice that there is a problem with medical supply and for example, these protection equipment, face masks, etc. That governments have now a stronger focus on national and local resilience and supply chains. And there's no doubt that renewable energy is, in the energy sector, the answer to that. So we do not see that in the long term there will be a negative impact, but rather the opposite, vice versa, because energy supply, once it's locally done, cannot be interrupted if there is an international crisis. What do we see as needful in order to indeed encounter the current crisis? And let me say, it's not just one crisis. No, we have the Corona crisis pandemic, and we also have the climate crisis, which some of us are still aware of. Of course, it is important to scale up massively the wind power deployment rates. We need to strengthen local and domestic supply chains. That's in the interest also of the industry, because if China, the Chinese, let's say, wind farm installation cannot continue because of there's no supply, then of course it's a problem that cannot continue. We need a stronger focus on local participation and investment so that the people are benefiting from it. I mean, we now really need to strengthen our economic activities as much as we can. And I think the focus now has to be on local activities first. That needs to be given somehow priority. Hand in hand with that is that really the governments now should look into how they can help the sector to grow. There are still barriers which are not very helpful. Sometimes getting a permission for a wind farm takes years and years and years. That's too long. That will not help. And of course, now it's time, and again, I'm sure that you heard about that the previous days, to develop not only wind power strategy, but a strategy for overall 100% renewable energy development across all sectors, and allow wind power to play its role. Now, some people now believe that well, sun is so beautiful and wind is super, but it's very clear that wind, sun, and the other renewables together, they are strong. Okay, I'm getting now some that my internet connection is weak. Can you still hear me well? There's no complaint. No, I'll just continue. So we really need to make sure wind power can play its role. It's not only solar. It's not only hydro anyway, but wind, solar, bioenergy, geothermal energy together must do it. So we need to have the corresponding frameworks which allow investors also to innovate. I think that's very important. That is what we learned from the last 30, 40 years. Once there was space for innovation, it was not the governments that created the innovation, it was the people. It was entrepreneurs, it was inventors which had a market and they could use what and could try out. Some technologies failed. But that is what we really now need, and not only focus on one specific technology, but on the integrated solutions. We've had a webinar with our partners from the International Renewable Energy Alliance. This is an alliance of the International Hydropower Association, International Geothermal Association, World Bioenergy Association, and International Solar Energy Society. And there we also discussed what are the consequences, what is the impact of the crisis, and what has the answer to be. And these were the conclusions from all the renewables together. So again, here, what we all agreed was we need to accelerate the deployment. We need to look into sectors that have not yet been covered, really. Heating, cooling, maybe that's the biggest challenge at this point of time. Transportation, now, of course, we see that electric cars are now starting to take over, but it's just starting. But in particular, the heating sector in those countries which require heating, a lot remains to be done and needs to be invested. When you look at these millions of houses, and usually you have rates of renovation of maybe 1%, 2% per year, that means it would take 50 to 100 years to replace the old systems. And that is, of course, far too long. We need to have the right financial incentives. So it's extremely important that in those recovery programs, there is enough space and also some incentives. But actually, we do not need so much subsidies. We need more the kind of free access to the market. We need that kind of support. No subsidies, of course, for fossil energies anymore, but I think that's very important. Now, it's of course good to hear that the European Union, with that huge program, also has earmarked quite a lot of money for climate change mitigation, and we hope and expect that also the renewable sector will benefit from that. Very important, third, mechanisms that meet other objectives than only lowest price and consider additional benefits and services of renewables when designing market mechanisms. I think that's very obvious. We do not only need to look at, governments shouldn't only look at who can supply wind at the lowest price, but the whole supply chain, how many jobs are created, what's happening in my country, the overall system costs are important to look into. So, and there's also an opportunity with that to create a just and inclusive, that's how we call it, energy transition that focuses on deployment, enabling and integrating policies and allows the full variety of investors to participate. Do not want to exclude anyone. Big companies should invest, individuals should invest, people like you and me, to have your own solar PV, but also buying a share in a community wind farm. Large corporations also must play their role. We need everyone to invest. And you see that in particular the OECD countries, how much money would be available is on the bank account without getting any interest. It shouldn't be a problem to raise the investment that is necessary. Again, it's the challenge is to mobilize and allow the money to be invested at the right place. Yeah, at the end, promotion and mapping and promotion of health benefits of a green energy-based economy. Well, with this, let me just conclude that indeed I believe strongly than ever before, we'll see we see twofold global paradigm shift. Before the Corona crisis, I was just speaking about the paradigm shift of renewables and non-emission energy replacing fossil and nuclear energy sources. Now, of course, with the Corona crisis, and we see the focus on creating more resilience, there is another crisis which finds its answer actually in the same area. Renewable energy is also addressing the problems in that sector, at least a major part of that problems. So with that, I conclude and thank you for your attention. And then I've been told that I may also be available for some questions or comments.
Can you hear me?
Yes.
Great. So before our participants create questions for you, I would like to ask, you said about necessary activities in the wind energy industry. In particular, we have to focus on local market players, companies, investors. Does it mean that we are staying on the doorstep of transition from huge farms, huge power plants to the local small power plants? Is it a new trend in the industry, or it's like a temporary because of problems today?
Well, if you look at it, depends, of course, on the angle. If you look at it from a perspective of your private household utilization, then even a wind farm with 50 megawatt is very big. But when you look at it from the angle of our previous and in many countries still existing energy supply system, where often you have several react, for example, nuclear reactors. So there is at one side, there's gigawatt of capacity. That's also the case in coal. Then, of course, this is not the future, and it's very, very obvious. And actually, this trend started long before the Corona crisis, that there will be a much more distributed generation. And there's a very interesting map, for example, from Denmark, where you see the electricity generation spots 20, 30 years ago, where there were only a few coal power plants, and now there are thousands of generation spots across the country. That's already a reality, but I expect that it will be stronger than that. So it's not that I expect that every house will just be have its own generation, but it will be more decentralized, indeed.
So this is the mainstream. I understood.
Yeah, that is very clear.
Yeah, the same like in solar energy in each of the segment of renewable energy. Okay, questions, guys? No. My next question, Stefan. How much time will the recovery take in wind industry now?
That is really a bit difficult to answer, because I told you we do not have yet the data for that. It's very simple. I cannot predict you. I can give you a little bit more indication in, let's say, I hope that we know in 2 months or so already what is the trend in 2020. And then based on that, because we do not know how much it will go down in 2020, based on that, it will also be much easier to assess whether there will be negative 2021 as well or not. And at the same time, we cannot predict now how or many of those countries are developing. You remember that the US went up, the number of infections, it went down, and now it's growing like crazy. If that happens again in autumn, then it may have a longer impact than if situation is now stabilizing all over the world. 2020 will be a difficult year, there is no doubt. 2021, I do not dare at this point of time to make a prediction. I expect 2022 will be a normal year again. And from that on, although I think we can expect even higher growth.
Yeah, I agree. But we hope that we will not get the second or third wave of this crazy pandemic, because it can kill all industries, not only renewable energy or wind energy in particular. So we have not actually the question, but it's something like comment. Some word, please, on the energy balance in the grid. I think it's something like a question: how to improve balancing in the grid that contains wind energy generation.
Yeah, so that it is of course not something that I can answer now right away, because I mean there are so many options. I know that this is still seen as a challenge by many people, but I can assure that there are many different options. On the first of foremost for wind power is of course wind forecasting, and that should not be done on the wind turbine level or wind farm level, but on a national level at least, so that you know how much power will you have, and that is quite precise now, let's say in 24 hours ahead. There is a lot that can be done nowadays with storage. We just heard that there's a new record of the power output from Tesla battery in Australia with 150 megawatt of output at a certain point of time. Of course, we have traditional backup systems, that is hydropower in particular. You can do a lot by grid management, also by the management of wind farms, etc. What I would just like to refer you to, we had early July, 2-3 weeks ago, we had a webinar on that. If you want to go into depth about which options are there, I just shared the link here. We had speakers there from Australia. They talked mainly about how they do it in Tasmania, in particular with hydropower. China, they talked about smart grid solutions. There is a lot, of course, with intelligent management of the grid, how India is doing it, how Denmark is doing a lot with decentralized combined heat power plants, for example, that Denmark has, of course, a quite high need for heating as well, in particular in winter. And then when they have an excess, for example, of wind power, they use it for heating. When there is not enough wind, and they increase the share of power from their CHP plants, which are mainly biomass driven. Or so that there are many different options. Again, I can just now start explaining a little bit, but you want to go a little bit more into depth and look at that. And you really need to see the national, local conditions. Technically, there's no problem to have very high share of wind power and also to run a 100% renewable energy grid. It's not a technical problem, more regulatory.
Yes, I agree. Great. Thank you, Stefan, so much. Questions? No questions. Stay safe and healthy there. I hope that we will meet in a couple of months in Kyiv and Krakow. I hope that everything will be okay and wind energy will be booming. All industries will be booming in the nearest time.
Thank you.
So keep in touch. Thank you again. And I want to invite our next speaker. Today, this is Victoria Walewska, the project manager of EDS project company. And we will discuss wind energy as a growth point for Ukrainian renewable energy sources. Victoria, turn your microphone and video on. Victoria, we can see your presentation, but we don't see you personally. Victoria, you already connected. Yes. Can you hear me? Yeah, I see you. Hi.
So did she tell you that? Did she tell you basically I was not on fire? So what did she do with it?
Okay. Is everything okay? Please let me know to our chat, because.
Okay. So here's what I'd like you to have a conversation.
Okay. Sometime not good internet can interrupt our connections. Okay. Victoria, can you hear me? Yes, but I don't. please turn the blue button on with the microphone. Sorry, your colleagues, it happened. That's why I love offline events. So before we start, I want to invite you to join our IB Club, the international professional renewable energy community, and you will get a lot of possibilities to communicate with your colleagues around the world to discuss cooperation, and just you can get a lot of interesting and very useful options like webinars, reports, and special books about different markets. Victoria, say please something.
Yes, hello.
Oh.
Where is my presentation? One moment.
So, yeah, your presentation. My colleagues will turn the presentation on right now. Yeah, that's it.
Very good.
So,
thank you very much.
Thank God we can start, so let's do it.
Good afternoon. My name is Victoria Walewska. I am project manager at EDS project, which is part of the EDS group. The topic of my speech, wind energy as a growth point for Ukrainian renewable energy sources. We are EPC contractors of electric power facilities. The main directions are construction of cable lines, electric substations, industrial power plants from renewable sources. In addition to construction, we calculate the models of electrical networks, modeling of storage systems, and means of forecasting the generation of renewable energy sources. To date, we have designed renewable energy systems facilities with a total capacity of more than 1 gigawatt. At the end of 2019, we took first place in the ranking of designers of solar power plants in Ukraine, according to Get Market. At this stage of energy development, Ukraine has set of course for European integration into the EN.Novation system, which will conceptually change the basics of electricity security and integrate the country into the European space as a whole. Entering the wind energy market is of interest to us. The provisions of the newly adopted Bill 3658 confirm that the development of wind energy in Ukraine receives significant preferences compared to the sun due to a slight reduction in green tariffs for these sources. One way or another, the current state of Ukraine generation capacity, a significant percentage of which is nuclear and thermal power plants. This is Ukrenergo's statistics. Will force us to develop alternative sources of electricity. 9 of the 15 existing nuclear power units have already exhausted their life, and their service life has been extended by 10-20 years. The design life of 3 more nuclear power units will end in the nearest future. The wear of the remaining power units is constantly growing, and they need to be reconstructed. Over the past year, a significant number of solar plant powers were built in the country, which was facilitated by attractive tariffs. Mankind hasn't seen such a pace of construction of power plants either during the coal energy or during the gas. Our specialists had to consider the impact of renewable energy system on the united energy system of Ukraine. It should be noted that now renewable energy sources don't play a significant role in ensuring maximum loads in the heating season, even when using power transfer systems for areas of graph of electric loads. Where there is a surplus of electricity to areas where there is a shortage. We are not witnessing to the so-called green coal paradox. Renewable energy is considered as an environmentally friendly source of energy, but at the same time it calls for increased electricity production to balance coal-fired power plants with harmful carbon dioxide emissions. Some of the investors we have worked with the intent to become participants in the market of ancillary services, which was created to regulate the frequency and active power in the united energy systems of Ukraine and maintain the parameters of reliability and quality of electricity. The structure of the frequency and power control system consists of 3 reserves. First, the primary, the frequency maintenance reserve. The secondary, the frequency recovery reserve. And the third, the voltage and power control reserve. to consider the possibility of connected participants to the market on auxiliary service, we perform a feasibility study of the connection of battery storage system BESS to the United Electrical Systems of Ukraine, with the possibility of using smart grid technologies. The main problem of implementing this system as a primary reserve is compliance requirements, the conditions of which don't currently take into account the use of BESS. Although the exciting system of payments for ancillary services doesn't stimulate investors in the necessary way, as it happens on the example of fiscal incentives for the use of saving systems in the USA, where payments include subscription fees for the ability to provide service, not just for actual electricity supply, which must be provided according to the commands of the dispatching department of the United Electrical Systems of Ukraine. Another problem is the imperfection of forecasting systems. We are currently conducting a comparative analysis of renewable energy forecasting system at the implemented stations to determine their efficiency. One way or another, the strategy for the development of renewable energy sources provides for the suspensions of new construction of solar power plants at a green tariff due to over-fulfillment of plans. As for wind farms, we have an experience in the construction of 330 to 35 kilowatts power substation to connect a 500 megawatt wind power plant in the Zaporizhzhia region. We construction cable lines to supply the wind farm in the Kherson region. Now we are working on a wind farm in the south of Ukraine with the support foreign investors. We are seeing interested in building wind farms. There will be wind. There is need to develop and complete the necessary capacity, especially in scale areas. Thank you for your attention. If you have questions, you can ask me. Якщо ви хочете задати питання українською мовою, можете задавати.
Okay. Can you hear me? Hear me, Victoria?
What? Can you repeat?
Can you hear me? Everything is okay?
Yes.
Because I suppose that my internet is not good now. Okay. No questions? maybe Victoria, thank you. Thank you for the presentation. I wish you to get a lot of new clients, your company in the wind energy industry as well, not only in
Thank
solar
you.
industry. So thank you. I'm happy to invite our next and last speaker for today. It's Mr. Troy.
Very much.
Thank you. Yeah, it's Mr. Troy Miller, sales leader, energy storage, North America in the company General Electric Renewables. Troy, happy to invite you and happy to see you in our event.
Please let me know if you can hear me and you can see me.
Hello, Mr. Miller.
Can you hear me and can you see me?
Yeah, the picture is great and the sound is very well.
Excellent.
Thank you for joining our event.
Thank you for having me. I appreciate this. Let me know when you would like me to start.
We can start.
Shall I start?
Yeah.
Okay. Wonderful. So thank you for inviting me to this event. I'm happy to be here. My name is Troy Miller. I am the North American sales leader for the energy storage team at GE Renewable Hybrids. I also serve on the board of directors for the Energy Storage Association, and I'm a member of the executive committee. The Energy Storage Association has been around for about 30 years and has been as a non-government organization based in Washington, D.C., that has been advocating for regulatory and legislative effects to level the playing field for energy storage as it relates to other forms of generation. So I'm happy to be here. I'll talk for about 20 minutes or so and then leave some time at the end for questions. I want to make sure that I know how to advance the slides. I've not done a test on this before. So do I have to ask you to advance the slides or can I do that with the down arrow? Conference organizer. Aha, I see it now. Okay, going back. There, learning the technology, it's always a challenge. So this is the first time I've used the Get Response platform. So thank you for bearing with me while I understand. So there are big and powerful trends. I'm not telling anything that you don't know, but there are big and powerful trends shaping the nature of electricity. The world is transitioning from a system based on large centralized generation and transmission to one that embraces distributed, digitally enhanced, and low carbon technologies. Decarbonization, more renewables obviously is happening, and it's leading to an enhanced need for grid stability and flexibility. And a growing number of these devices are monitored and controlled in real time that has big data sets and very good analytics for asset performance management, as well as applications to better enhance the decision making and improving the overall grid reliability and efficiency. A distributed generation, solar in particular, places a great strain on the grids, which were built for one way and now are multi-directional or even islanded. This is driving on-site renewables, microgrids, and storage. And the electrification of the overall energy platform and our energy and transportation are converging with the adoption of electric vehicles. And beyond load growth to fuel these vehicles, there's going to be a tighter interconnection with the power grid as it relates to electric bus, truck fleets, ferries, and there'll be a big impact on these electricity markets. GE Energy Consulting has put together a very great white paper that's available for download on our website about the energy markets in transition. We have a large interest in because of our position in thermal and wind applications, we have a large interest into where these generation platforms are headed. So renewable energy is mainstream now. Wind and solar have reached grid parity in many markets and are now the cheapest source of energy in 2/3 of the world. Renewable penetration will continue to increase and is estimated that around 70% of all new global installs from now until 2030 will be renewable. Gas, steam, and nuclear generation will still prevail with around 4,600 gigawatts of installed capacity in 2030, according to our estimation. However, in this context of increased renewable penetration, there's a need for solutions which decrease the variability and allow renewable energy to be supplied when and where needed without impacting grid reliability. Many of these challenges can be solved through hybrids, integrating storage in the form of battery energy storage systems or even pumped hydro into larger or green hydrogen into larger applications of existing generation and new generation, solar, wind, and thermal. As an illustration, this is what we envision the future of the grid will look like. One that is high in renewable penetration, able to overcome grid obstacles with the help of storage and hybrid solutions, and is supplemented by a small amount of thermal generation for long-term contingency events. A hybrid system is a combination of multiple generation sources and or energy storage. In this case, you can see the example of a DC-coupled solar plus storage plant, which is integrated behind the same point of interconnection and operated with a single control system. The co-location of solar and storage allows for energy shifting and firming, avoiding curtailment, and making the otherwise variable asset dispatchable. Additional services such as frequency regulation can be provided to the grid. A DC-coupled solution has the advantage of higher DC to AC ratios, increasing the overall capacity factor of the project. DC-coupled systems also have lower round-trip efficiency losses and less CapEx associated with the transformer, inverter, and cables, improving the overall economics of the project. In addition to power electronics, hybrid systems are enabled by controls and software that act as the brains of the system. Hybrid control systems allow the integration of co-located generation assets at a farm level, enhancing grid compliance and revenue stacking. Hybrids are software-defined systems that can become smarter over time, providing the possibility to change operation as changes take place in weather conditions, power demand, market prices, rules and tariff structure, battery technology, and or with unexpected operational issues or failures. This ensures that revenues are maximized and costs are managed and optimized throughout the life of the hybrid plant. We've seen many RTOs increase their ability to provide new services like capacity, power factor compensation, and frequency regulation. In the case of ERCOT, there's a different price for reg up versus reg down. We're seeing different capacity rates, and so if you've got a properly operating hybrid controller, you're able to take advantage of the changes in the marketplace as they occur at the ISO and RTO level. Now, storage solutions enable multiple business cases from standalone systems delivering grid reliability to co-location with thermal and renewable assets in front of the meter or behind the meter for distributed or microgrid applications. These also span from short duration power applications to deliver grid services to long duration applications that enable energy shifting and the dispatchability of renewable assets. An interesting case is that of the enhanced gas turbine, where co-location of storage can help optimize the use of an asset. Our systems are fully modular, called the GE Reservoir, and based on an 8 by 20 footprint that can be deployed in all of these use cases, either AC or DC coupled. A 2.5 megawatt inverter in a 20-foot footprint and 4 megawatt hours of storage in an 8 by 20 foot footprint. Here you see the integration of gas turbines and a battery energy storage system to enhance the flexibility, reliability, and response time to energy demand. It allows a more effective use of renewable assets in the system and faster response to changing demands. It reduces the environmental impact and operational costs. The specific project pictured here was executed in partnership with an EPC partner called Wellhead and is made up of two 10 megawatt, 4.3 megawatt hour fully integrated with two LM6000s. These are 50 megawatt peaking power plants based on aeroderivative engines. It earned the ESNA 2017 Innovation Award and the 2017 Edison Award, the most prestigious in the electric power industry. It saves 2 million gallons of water per year. It reduces the starts and stops by half, which translates directly into fuel savings. It reduces greenhouse gas emissions and other emissions by as much as 60%. The hybrid system allows the turbine to operate in standby mode without combusting fuel, which lowers emissions, while the battery stored energy enables immediate response to changing energy dispatch needs. They operate under a single interconnect. The interconnect was 50 megawatts for the peaking power plant, and we added 10 megawatts of storage onto that interconnect, not changing the interconnect. So we had 50 plus 10 equals 50. We never went above the 50 megawatt interconnect. And Southern California Edison said in a filing to Cal ISO about 1.5 years ago that this particular installation in the LA basin had the highest return on investment of any of the energy storage systems that they had previously deployed. As we are all aware, and in light of recent incidents, safety is of utmost importance in the industry. Proper system design, component validation, and operating procedures are the key to reducing the risk of a safety incident and to protect the life and property should such an incident occur. When it comes to safety, risks are mitigated within the individual battery cells, but most are mitigated through the overall design and control of the system. Whether you're a developer, a supplier, or a customer, ask yourself how to mitigate known risks. You want to make sure that every risk has at least one control to mitigate it. For example, GE is taking care to source lithium-ion batteries from Tier 1 suppliers with products that have a proven track record. GE's overall scheme utilizes multi-layered protection with overlapping zones, which is laid out here in detail. GE's proprietary battery protection unit, otherwise known as the BPU, is designed to isolate affected batteries and racks from the system should their safe operating limits be exceeded. The battery protection unit allows for a decrease by 5x of the short circuit capacity in each of our energy storage containers. Hybrid projects have become a reality. Regional dynamics drive different hybrid approaches, but it's clear that hybrids are now a reality. There's a growing trend in solar plus storage and wind plus solar plus storage hybrids in the US and Australia to avoid curtailment and improve firming and dispatchability. GE, as illustrated before, has pioneered in the deployment of enhanced gas turbines. We are seeing the first wind plus storage hybrids as markets continue to develop and the economics of battery storage continue to evolve. Here's a particular project that we're installing as we speak. It's an innovative DC-coupled solution that improves the solar yield and the overall efficiency of the system. DC coupling allows for a higher round-trip efficiency because it has one less conversion. And there's less CapEx as the PV arrays connect directly to the inverter unit of the battery. The reservoir storage unit allows for direct coupling of either DC or AC coupled systems because of the previously described blade or battery protection unit. We're integrating two PV solar arrays here, built with two energy storage systems, directly DC coupled through that single inverter and that single point of interconnection using a single hybrid control shared by the array and the storage system. This is in line with New York's vision of reforming the energy, and we're allowed to shape the output, and we are providing a one-to-one solar plus storage application. So there's for every megawatt of storage, there's a megawatt of solar, and they're able to capture the VDER credits that are allowed for NYSERDA. This is a thermal hybrid that we have constructed and has been online since the end of 2019. GE successfully completed the first energy storage assisted black start of a 7F turbine at a 150 megawatt simple cycle plant in Louisiana for Entergy. This milestone project serves as a potential model for future projects in GE's F-class turbine fleet of 900 units in service, servicing 150 gigawatt of power in 12 countries. It was put together using three 40-foot shipping containers loaded with 21,000 lithium-ion cells for 7.4 megawatts and 7.4 megawatt hours of energy. The system will also be utilized to provide ancillary services when it's not being used for black start. Here is a capacity and fast response in the UK. We've supplied a fully integrated 41 megawatt hour energy storage solution that provides on-demand power to 100,000 UK homes. The project relieves pressure on the electrical grid and provides flexibility when it's needed, providing balanced, secure energy system for those UK customers. Our solution combined the GE control as well as the customer's advanced control technologies, and has been providing services on our customer's trading platform. It can provide multiple grid services simultaneously, frequency regulation, and capacity during those system stress events. It was the first system to be built on merchant only in the UK, and it was built on a full turnkey basis utilizing an existing building. We provided the inverters, the racks, the balance of plant, and the fire suppression and the design. According to a recent study published in the Journal of Applied Energy, capacity avoidance or capacity deferral is the biggest source of value for energy storage in that long run context. Storage can displace capacity investments in three major ways: by reducing the variable renewable investments. Storage can shift that generation that would otherwise be curtailed so that the system delivers more clean electricity production from a given amount of renewable capacity. Can replace thermal generators, mainly peakers, for peak hour electricity delivery. Storage is well suited to knock off peakers and that rarely run, like we've seen with the LM6000. and are only operating for a few hours at a time. This is starting to happen in very select markets. And using storage as a transmission upgrade deferral by holding power during congested periods and delivering it when wires have more capacity. Here's a slide about what we're doing in GE Renewable Energy. We have 15 billion in revenue and 40,000 employees and are working across the spectrum: onshore, offshore wind, blades, hydro. We're committed to making sure that no one is ever limited to only affordable, reliable, and sustainable energy. Hybrid solutions are a fundamental piece of the equation, and through our portfolio, footprint, and expertise, we have what it takes to make this happen. So now I'll open it up for any questions that you might have. I'm not sure of the format, if you can speak over this format or if you type them into the window, but please ask away.
Troy, thank you so much for your presentation. Can you hear me?
Yes, I can hear you. Hopefully you can still hear me.
As a shareholders of General Electric, I have about 10,000 stocks of this company. I follow the news about the company, and as you know, yesterday General Electric signed a contract with the British company Uniper about new project in the United Kingdom. It will be a new power plant that will be using natural gas. But my question is, will this company use solutions that you showed here in your presentation? I mean, these intelligent solutions.
I can't speak to the specifics of this particular project. I did see it. We are working across the GE platform. And so in this case, it would be GE Power to provide at minimum a black start using these energy storage systems. So I can't speak to whether or not that will be in this power plant, but it could very well be. Black starting using energy storage is a very attractive alternative to other solutions that might be out there. There's also the possibility, depending on how often the system will not run at level load, to hybridize that system at some level. So providing energy storage to enhance the flexibility and the P=0 cross of the system.
Great. The next question. Do you plan to create such product, something like product of sun power in the United States? You know that this company now provide comprehensive service with solutions with energy storages. So it's something like domestic product. Do you plan to do something like this? Because you know that utility scale segment is booming now in the United States.
Could you repeat the first part of your question? I want to make sure that I understood.
The first part of my question, do you plan to create new products like sun power's domestic energy storages?
So we are manufacturing a good portion of our systems domestically, but I think your specific question was. Yes, I can hear you. Can you hear me?
My internet is not good.
Sorry, I hear you fine. I can hear you. I'm not sure if you can hear me.
The problem from my side.
So domestic
Troy,
supply.
can you hear me?
I can hear you. Yes. Yes, I can hear you.
I can't. My assistant told me that everything is okay, but I can't hear you.
So I will answer the question. I'm assuming your question is in regards to the supply of the energy storage racks, the lithium-ion batteries. There are alternatives domestically supplied, but not enough to take care of the overall market as it exists. So that is something.
Troy, sorry, can you hear me?
Yes, I can hear you. Can you hear me? I'm assuming your question is in regards to the supply of the energy storage racks, the lithium-ion batteries. There are alternatives domestically supplied, not enough to take care of the overall market as it exists. So that is
Troy, sorry, can you hear me?
Yes, I can hear you. Can you hear me? I'm assuming your question is in regards to the supply of the energy storage racks. There are alternatives domestically supplied, not enough to take care of the overall market as it exists.
Oh, I got back.
Okay. I'm here. Can you hear me okay now?
I'll get back. Sorry for this technical problems. It's internet. Troy, thank you so much for your presentation.
Okay.
Fortunately, I missed your answer before, but now, thank God, everything is okay.
Okay.
Thank you again for the presentation in interesting information about your solutions. Definitely, this is our future. This is the future of our energy industry,
Yeah.
and I hope that we will see a lot of very good news for your company and for industry in the segment of energy storages and in intelligent solutions for power plants. So thank you. We'll be happy to see you personally in our next event in the United States and Europe as well. So stay safe and healthy, and thanks again.
Thank you so much. Thank you for having me, and I appreciate your attention. And please reach out to me if I can help in any way. Thank you.
Thank you, Troy. So, dear participants, I would like to to say thank you for your passion, for your interest, for your time, and I want to invite you to join us tomorrow. We're gonna start at the same, no, not the same, at 2 p.m. Central European time. We will have a lot of interesting presentation about biomass, about storages, and about last intelligent solutions for energy industry, for projects in the field of renewable energy. So thank you again. Have a good day today, and join us tomorrow. It will be interesting and